All right, welcome back. We're going to continue lesson 39, the upper and lower sums, to find the area under a curve. Okay, area under a curve is very key to calculus. Okay, and we'll talk, it'll probably be in tomorrow's video, about what actually that means and how we can find it really quick and not have to use the methods we're using right now. But right now, this is what we're doing. Okay, it's kind of the why. Why do we use the definition of a derivative if I've got this quick shortcut? Well, you kind of just need to know where it comes from. Okay, so I'm going to try to wrap it up today in a shorter video. I'll probably have to do one for tomorrow. So, use upper rectangles. So we're going to use upper rectangles to estimate the area under the curve, y equals negative x squared plus 9 on the interval from 1 to 2. And they're specific, they want you to divide it, I'm yelling, divide it into 5 rectangles. So they'll say n equals 5 rectangles. And that's different. Dividing it into 4 was really easy. Dividing it into 5 is a little bit more tricky. Okay? So we're going to start with a graph. Okay? So I'm going to put, like I did the last time, our grid paper up here. And then we're going to take this to be up bigger. Oh, maybe not quite that big. That is perfect. Okay. So I'm going to draw my graph. We know it's not negative. I probably don't even need to go that far that direction. And then up and down, I'm probably going to have to scroll down. Okay. So I'm going to scroll down because we don't need these purple words. I need those purple words. So I'm going to scroll this piece down a little bit. Oh, I forgot I did it in 2 pieces. This down there would be good. Okay, so we need to know, where is this graph? Negative x squared plus 9. So you can plug in your calculator, or you can start plugging in numbers. It was x is 0, we're at 9. So it's way up here at 0. We only want the interval from 1 to 2. So I'm going to go, as each 2 of these are 1. So there's 1 and there's 2. Okay? So at 1 squared is 1. Then it's the negative. So negative 1 plus 9, we're at 8. Oh my goodness, we're still high up in all my words. I knew that might happen. Maybe I need to scroll down a little bit more. 2 squared is 4. So now I'm plugging in 2. 2 squared is 4. Negative 4 plus 9 is 5. 1, 2, 3, 4, 5. So that should be 5, and that should be 8. Ugh. I'm not going to connect my dots. What if I was at 3? What was 3 squared? That would be 9. Negative 9 at 3, I would be at 0. Okay, I know that's not in our interval, but it comes down pretty quick. And it's kind of like an upside down parabola if that was there and nice. Okay, so we're looking between 1 and 2, and we want to find what's the area under this curve. Maybe I will erase some things. Okay, I'm going to erase that, and I'm going to write it over here into n equals 5 rectangles. So I'm not in the middle of all of my stuff. We're trying to find the area under the curve between 1 and 2. The first thing we're going to do is figure out, well, this interval, I need to divide it into 5 sections, right? So in 5 sections, they do a little formula. If you do b minus a over n, that will tell you your section, the length of each sub-interval, okay? So that is actually 2 minus 1 over 5, which is 1/5, or 0.2. They do decimals in this one. I don't know why, but they do. That's okay. 0.2 or 1/5. So we're dividing this into 5 rectangles. And it says upper rectangle, so we have to come on the outside. Okay? So it's not all the way half. It's about right here. Oh. And then it's right here. 2. And then it's right here. 3. Their picture is so much better. 4. And the last one would end right here. Okay? So if you can see all 5 of those rectangles, okay? The biggest piece is, what is my output at each of these points where the rectangle hits the curve? Okay? So in the upper rectangle right now, it's hitting on the left. Okay? So we would start with using that. And so ultimately, these dots that are in red, I should have 5 of them. Okay? I should have 5 dots that I'm going to have to find f of x. So I'm going to have to find the y value at each of those points. Okay? Now the base of each rectangle is how far? 0.2. Not 0.5, it's 1/5. 0.2. So remember that formula. The area under the curve is the base times, I'm pretty sure they do a bracket, 0.2 times f of the first point, f of 1, plus f of what? What's our next point? What's this point? 1.2, plus f of 1.4, plus f of 1.6. So that's 4 points. Oh, I just need it to be over just a little bit more. Imagine that. Oh, it's not going to do it for me. Never mind. I thought I could just move it over. Plus f of 1.8. And that's the end. So that would be f of 1, f of 2, 1.2, f of 1.4, f of 1.6, f of 1.8, and we don't even get to 2, okay? So, ultimately, I probably will pull out my calculator so I don't have to go through and figure out what this is. Because each one of these, I'm going to have to plug in this negative of 1 squared plus 9, which we already found that one. That is my f of 1. Okay? But then I'm going to have to add it to negative of 1.2 squared plus 9. Okay, now my calculator's going to pull up. So if I have a value of an equation, and my equation is negative x squared plus 9, okay, and I need to calculate, second trace, I want to find the value. They graph it for you right there. We already know what the 1 is, right? F of 1. We'll go ahead and plug it in. What is 1? It's 8. So this first value is 8. Okay? Then what happens? I would have to hit second trace again. Value of 1.2. Hit enter. I get 7.56. Okay? Next, I'm keeping on going. That's why this equation is so important. That way I already have all my points that I'm looking for. Okay? I need to find the value at 1.4. And it's 7.04. Okay, I'm on the fourth one. So I need second calculate at 1.6. The value of 1.6. And I'm at 6.44. Again, it didn't, my f of 1.8 is not going to lie on that same line. Okay, second, calculate the value of 1.8. And I get 5.76. Okay, so now I have to go add up all those numbers. I'm going to quit. I'm going to clear all this out. And I'm going to say 8 plus 7.56 plus 7.04 plus 6.44 plus 5.76. I think I put all those in. When you get all these numbers, I have to double check. So now that was all of my f of 1 plus f of 1.2 plus f of 1.5. I still need this 0.2 times all that. So I need 0.2 times 34.8. So I'm going to hit times 0.2. And that area of all of these rectangles is 6.96. Excuse me. So that's the area. Now, is that an upper estimate or is that a lower estimate? Okay, well, the rectangles, they went outside. They went in this triangle, or this rectangle with that much out. It's too much, right? And this one, it gave me more. Okay? So this 6.96, the area, the actual area, is less than 6.96. Okay? Now, I want to do something. I'm going to minus this. And I want to look at this exact same curve over the exact same interval, but this time instead of having 5 intervals, 5 sub-intervals of this 1 to 2, what if we had, let's say 8 intervals, okay? So we're going to take the exact same equation, y equals negative x squared plus 9, and I want over the interval from 1 to 2, but I want it in to equal 8, okay? I want to subdivide it into 8 sections, okay? So my b minus a, so 2 minus 1 over 8. Each rectangle will be how wide? Yeah, it's going to be 1/8, or, oh my goodness, 0.125. Okay, so, again, this time I'm not going to draw the actual graph. I'm just going to draw a freehand because then I can estimate, or I can, okay. So we know at 0 we're at 9, and then we're at 8 at 1. So here's 1, okay, and I'm looking to start right there, okay. So we're going to say that's 3, and this is 2. I don't want it to be that close together though. I'm going to erase. Start over just a little bit. So my 1, I'm going to exaggerate my 1 to 2. Okay, just going to do it. Okay, so that it's coming here. 8 and then at 2, it was 5. This is 5. And I want to find the area under here. But this time, I don't want 5 sections. I don't want 4. I want 8. So I'm going to divide this into 0.125. So, I go divide it in half, and then divide that in half, and then divide that in half. That should be 1, 2, 3, 4, 5. So that should be 1, 2, 3, 4, 5, 6, 7, 8. And the base of each one is 0.125. Okay? So, each rectangle, if I still do the upper sum, okay, I'm not going to draw them all because that gets a lot of rectangles in there, right? But my formula would still be the same, the base, the distance of the base. Okay, so 0.125 times. The only thing you have to figure out is upper sums. Are we going to start at the left side, do I need to use f of 1 or do I need to start later? Okay, so that's why visual is good because I can see, yep, I'm going to have to use f of 1. And then I'm going to have to use f of 1.125 because I'm adding that to it. And then I'll have to have f of 1.25. So here we go. I'm going to pull out my calculator. 1.25 plus I'm going to have to add 0.125 to that, and I'll have f of 1.375, and then I'm going to have to add 0.125 to that. I'll get 0.5, so f of 1.5. I'm at the exact halfway point there. Okay, after 1, 2, 3, 2, 3, 4. Yep. 2, 3, 4, I'm at the halfway point. Okay? Then I'm going to have to add f of 0.125, f of 1.625. Then plus 0.125, f of 1.75. Plus, I think this is the last one, plus f of 1.875. And I should not get to 2. So this point right here is the last one that's going up to hit to go over. Okay, so I will not use f of 2. Now, should I have 8 of these pieces? Let's go back and count them. 1, 2, 3, 4, 5, 6, 7, 8. There are 8. Okay? So, I'm going back to my calculator. I have the exact same equation in here. So, I'm going to go to y equals. I'm going to leave that in there. We know f of 1 is 8. Now, I'm going to hit second calculate, and I'm going to hit a value of 1.125. Okay? Now, I'm not going to give every single decimal. 7.73. Probably just going to give 2 decimal places. It's not going to be perfect. It's not going to be accurate. Okay? F of 1.25. And I'm at 7.44. So one of them was a little below. This one's a little above. I rounded up. Second calculate. Value. 1.375. And I'm at 7.11. Just pick a thing and just round to that second digit. It's perfect. I'm on 1.5. Value. 1.5. And I'm at 6.75. And I'm literally counting 1, 2, 3, 4, 5. I'm at the 6th one. So I'm going to hit second calculate. This is just time consuming. And you'll be very mad when you're like, hey, there's a shortcut? Sorry. 0.625. But it's good to know. So here we have 6 is 6.36. Second calculate. Value. What happens if we divide it into 20 intervals? Okay, we will get a better approximation to the area the more we divide it into. Calculate, the last one is 1.875. We're at, oops, I didn't put a 1, sorry. Second calculate, that can't be right. 1.875, not O. And I'm at 5.48. Okay? So, and I know they have to be going down because this graph is going down, so the y value has to be decreasing. So I'm going to start adding. I'm going to get a little closer because it gets blurry on me. 8 plus 7.73 plus 7.44 plus 7.11 plus 6.75 plus 6.36 plus 5.48 plus 5.48. Okay? So we've got this big number, 54.81. That was all of our F of stuff added together. But what are we multiplying? What's the area of the base of all of these? So I'm going to hit times 0.125. And I have 6 point, so the area, approximate area, is 6.85. What was our last approximate area? I'm going to go backwards. 6.96. So the area with 5 sections was 6.96, if you can see it there at the bottom. The area with 8 sections was 6.85. Is the area still going to be less than 6.85? Yeah, because there's stuff out here. Well, if we divided it into 20 sections or 50 sections, would we get a better approximation? Yes, we would. But who in the world would want to do this process for 50 intervals? So did they have to come up with something that would make it easier? Okay? So I'm going to show you really quick. I told you I was going to wait till tomorrow. So if you made it to the end of this video and you're still here and you're still listening, it's actually this wonderful thing right here. Okay? And what is that wonderful little elongated S? It is the interval. Okay? So if we take the interval, now in different places that maybe you've seen, they'll put numbers at the top and the bottom. Okay? And it's all about the interval from 1 to 2. So whatever you're going to, whatever your interval is, you can put it at the bottom and at the top. And you take the interval of negative x squared plus 9. And really there's a dx there. Okay? And if you take the interval, you can plug in some numbers. I'm going to do this right because I didn't refresh my brain, and that's probably very scary because I wasn't planning on telling you this today. But it's an awesome thing. So intervals. So I have to remember, we did this just last week. Integral of a sum we can pull apart, correct? The integral of one piece plus the integral of another piece. So I'm going to pull a negative out. This would be my constant, negative 1. Pull it out, and what's the integral of x squared? X cubed divided by 3, correct? So that negative just stays there. And then what's the integral of 9? Yeah, it would be 9x. Okay, if we take the interval, and these numbers are out here, they actually put a line from 1 to 2. And you're going to plug in this 1 and this 2. So I'm going to plug in negative of x cubed, well, not x, I'm going to actually plug in 2 and 1. So I would say 2 cubed over 3 plus 9 times 2. Okay, so I plug in my top interval into where I see the x's. See it? Okay, so 2 cubed, I think, is 8/3. So negative 8/3 plus 18. Okay, and I always forget, I'm 99.5% sure that it's a subtraction sign of what we're plugging in the bottom. Okay, so now you're going to plug this 1 into the x's, and we're going to subtract the values. Okay, so this first piece, that's with my 2 being plugged in. Okay, now I'm going to plug in the 1. So here we go. Negative 1 cubed divided by 3 plus 9 times 1. Okay, so now I have negative 1/3 plus 9 here in my second spot, and I will subtract these pieces. Okay, so hold on just a second. I'm going to scroll if I can so we can all be here. I got to have my calculator because I'm just going to do decimals if that's okay. Or, watch this, I'm going to pull it up right here. We've just had this out, right? So I'm going to say negative, parentheses, negative 8/3 in parentheses plus 18. I just don't like too much. I'm going to say that's 15.333. It's the 1/3, right? That's the repeating. Minus, this right here is really just 8 1/3, right? 8 2/3 technically. 8.666, but I'll go ahead and put it in my parentheses. Negative 1/3, not 1/2, 1/3, plus 9. Gives me 8.66. Okay, so now I need this first number minus the second number, and I get 6 2/3. Guess what that 6 2/3 is? Does it look very similar to this number we got before? Okay, yeah, this is my approximate, the high end. My actual exact area under the curve is actually 6 2/3, or 6.6 repeating. Okay, so the more intervals that we do, the closer we're going to get to the 6 2/3, or 6.6 repeating. Integration is amazing, and that's what they talk about with the area under the curve. I gave you the secret early. We'll come back tomorrow and do one more, have a quiz, and then a test this week, and we're done. What? I know, it's awesome. You guys are doing good, and we're almost done. Can't wait to see you. Bye.